day everyone, I'm Denver J. Lamiar from ECE1D, and today I'll be talking about a breakthrough in clean energy, high-efficiency electrolyzers, and how they power the rise of the green hydrogen. Green hydrogen offers a path to a zero-carbon future, and electrolyzers are the technology making that possible. Now let's proceed to the objectives. By the end of the presentation, you should be able to, number one, understand the green hydrogen is and how electrolysis works. Number two, identify the main types of electrolyzers. Number three, trace the history and evolution of this technology. Number four, learn about current application and innovators. Number five, recognize how this technology supports global sustainability. Let's begin with the basic. Green hydrogen is the hydrogen gas produced by splitting the water or H2O using renewable energy using a process called electrolysis using electricity like solar or wind power. Why is this important? Because the traditional hydrogen is also called the gray hydrogen is made from fossil fuels like natural gas and it emits CO2. But green hydrogen emits a zero carbon during production. It's clean, flexible, and powerful. It can be also used on fuel to buses, trucks, and trains, power industries like steels and chemical manufacturing. And it can also store excess energy from solar or wind farms. However, this is not perfect and still faces challenges like high production costs and some energy efficiencies and need to new transport and storage infrastructure. So what is an electrolyzer? So how is green hydrogen actually made? That's where the electrolyzer comes in. An electrolyzer is a device that uses electricity to split water into hydrogen and oxygen, a process called electrolysis. It's the central machine behind green hydrogen production. There are three main types, each suited to a different situation. Number one, proton exchange membrane or PEM. Number two, alkaline electrolyzer. And number three, the solid oxide electrolyzer. Let's look at each type more closely. First is PEM electrolyzers. Use a solid polymer membrane instead of liquid. They operate at low temperature around 70 to 90 degrees Celsius and have a fast startup times and high efficiency. Here's how the chemical reaction works. At the anode, they make the oxygen, and at the cathode, and what you can see, the 2H++ electron is making the hydrogen. Overall, 2 molecules of H2O or water can yield into 2 hydrogen molecule and oxygen. A real-world example is Nel Hydrogen M-series electrolyzer uses in hydrogen refueling station, such as those for buses and trucks in California. It's fast, compact, and perfect for transportation. Alkaline electrolyzer. This is the oldest and most established type. It is used a liquid solution like potassium hydroxide or KOH to facilitate the reaction. It operates at 60 to 80 degrees Celsius and it is cost effective and reliable, especially for large-scale operation. The chemical process is a bit different. At anode, here is the process and the cathode, they produce the hydrogen. Overall, it's the same. two molecules of H2O or water can produce a two hydrogen molecule and one oxygen molecule. A great example in real-life adoption or application is Yara's ammonia plant in Australia, which used NELS A series electrolyzer to make a green ammonia, a sustainable fertilizer. Solid oxide electrolyzer. Solid oxide electrolyzer work at a very high temperature, around 700 to 1000 degrees Celsius. They use a solid ceramic electrolyte, making them extremely efficient, especially when integrated with the waste heat. Here's the chemical reaction. Anode, there's the reaction, and cathode, there's the reaction. Overall, is the same. Two water molecule is yield into two hydrogen molecule and one oxygen molecule. These systems are still being developed, but companies like Sunfire and Nel Hydrogen are planning to use them for industrial scale hydrogen production. What's the comparison table of the three types of electrolyzer? Let's compare the three types. The features of alkaline, PEM, and solid oxide. The electrolyte of alkaline was the liquid KOH, and PAM is solid polymer, and solid oxide was solid ceramic. And each temperature has, in alkaline, 60 to 80 degrees Celsius and in PEM is 70 to 90 degrees Celsius. In solid oxide was very high, which is 700 to 1000 degrees Celsius. And startup speed was, in alkaline was moderate, PEM was fast, and solid oxide was slow and needs heating because it's very high temperature. And its efficiency, alkaline was good, PEM was high, and solid oxide was very high. In maturity, alkaline was most mature, PEM is commercial use, and solid oxide was in still developing. In recommendation to best use, in alkaline was ammonia industry, PEM in vehicles, and solid oxide was in heavy industries. Each has unique strength, and PEM is fast, alkaline is cost efficient, and solid oxide deals with a large energy intensive facility. These slides have a video. Watch this after the discussion. It's very helpful to you to understand the most of what I'm talking about. Thank you. For now, let's talk about the history of electrolyzers. Let's take a quick look at the history and evolution of green hydrogen. In 1800s, Nicholson and Carlis discovered the electrolysis. In 1890s, first industrial scale alkaline electrolyzer appeared. In 1970s, the oil crisis spurred and development of PEM system. In 2000s, solid oxide electrolyzer or SOECs began to being researched. Today, efficiency above 90% are possible. New technologies like AEM or anion exchange membrane are emerging. And in the future, we're aiming for gigawatt scale production, AI optimizing systems, and go for producing hydrogen for less than $1 per kilogram. Now let's proceed to the real-world application of green hydrogen. Green hydrogen is already used in worldwide. And industry decarbonation was green hydrogen replaces fossil fuels in steels, chemicals, and refining. And transportation fuels fuel cells, electric vehicles like trains, buses, and trucks run on hydrogen. Energy storage, excess solar or wind energy can be converted into hydrogen and stored for a later use. Export markets, countries like Australia are exporting the green hydrogen to Japan and Korea. This shows how flexible and valuable hydrogen is across many sectors. Let's proceed to the global innovators. Many companies around the world are leading in electrolyzer innovation, like in Nel Hydrogen in Norway, PEM and alkaline system they use. In ITM Power in UK, United Kingdom, focus on large PEM system. Bloom Energy in USA, solid oxide electrolyzer. Hysata in Australia, developing system with 95% harder efficiency. ThyssenKrupp in Germany, scalable alkaline system for industry. In Hydrogen Pro, Siemens Energy and Plug Power, each contributing to build a global green hydrogen economy. These organizations are making the vision of a clean hydrogen future for realistic every year. Now let's talk about what is the challenges and opportunity of this green hydrogen. Let's talk about the challenges. High cost for electrolyzer and renewable power, and also massive energy demand to run a large-scale system. Then infrastructure gaps, like pipeline storage and fueling station are still limited, and unclear policies and regulations in some countries. There are also opportunities. Falling costs of wind and solar energy, government support of like Inflation Reduction Act in USA and UAE Green Deal, international collaboration and investment, and advance of materials and AI that boost efficiency. What is the benefit of a high efficiency electrolyzer? Here's why this technology is very important. Number 1, reduce the carbon emission in multiple sectors. Number 2, maximize renewable energy with less waste. And number 3, acts as a battery for a solar and wind energy. Number 4, support a circular economy by enabling green chemical production. And lastly, increases energy independence by using local resources. So why it is really matter? In summary, green hydrogen and electrolyzers offers a way to decarbonize sectors that are hard in electrify and store clean energy, reduce reliance in fossil fuels, and help us reach a net zero target. And all of this depends on making electrolyzer more efficient and scalable. To conclude, the green hydrogen is more than a fuel, it's a clean energy solution for the future, and electrolyzers are the tools making that future possible. From water to hydrogen and back to water. It's truly circular, clean process. Thank you for listening. I hope this presentation helped you understand how electrolyzers and transforming green hydrogen into a reality for a sustainable world.